Welcome back to Weld Fab World. This is Lecture 3 of our 18-part series on ASME Section 9. In Lectures 1 and 2 we completed Part QG, the general requirements that form the foundation of the entire code. You now understand what Section 9 covers, what the three qualification documents are, how variables are classified, and who bears legal responsibility for procedure qualification. Starting today we move into Part QW, welding. This is the largest and most detailed part of Section 9. It spans 5 articles, hundreds of paragraphs, and covers everything from how to write a weld procedure all the way through to the specific tests required to qualify it. This lecture covers Article 1, the General Requirements article. Think of Article 1 as the scaffolding that holds the rest of Part QW together. It establishes the framework, defines the three-document system at a welding-specific level, draws the critical line between welders and welding operators, and introduces the 4-orientation system for weld positions that you will use in every subsequent lecture. It also introduces something critically practical: how to read the Article 4 variable tables. If there is one skill from this entire course that separates engineers who genuinely know Section 9 from those who just reference it, it is reading those tables fluently. We are going to make sure that clicks today. Let's get into it. Before we go any further, let me show you where we are in the overall Part QW structure, because knowing the map helps you understand why Article 1 is set up the way it is. Part QW is divided into 5 articles. Article 1, QW 100 to QW 199, General Requirements. That is this lecture. This is the framework lecture. It establishes scope, document relationships, orientation definitions, test position definitions, and test type definitions. Nothing in Articles 2 through 5 makes sense without Article 1. Article 2, QW 200 to QW 288, Welding Procedure Qualifications. This is where the actual mechanics of qualifying a WPS live: how to prepare test coupons, what tests to run, what the acceptance criteria are, and how to document the PQR. We cover this across Lectures 7 through 9. Article 3, QW 300 to QW 388, Performance Qualifications. Welder and Welding Operator Qualification, how to test a person rather than a procedure. Lectures 10 and 11. Article 4, QW 400 to QW 492, Welding Data. This is the data engine of Section 9, the variable tables for every process, the P-number base metal tables, the F-number and A-number filler metal tables, the position qualification tables. Lectures 12 through 16. Article 5, QW 500 to QW 512, Standard Welding Procedure Specifications. The SWPS system, how to use pre-qualified AWS procedure specifications without running your own PQR tests. Lecture 17. We are at the very beginning of Part QW today. Article 1, the foundation. Every technical concept in the later lectures builds on what we set up here. W100 opens with this statement: the rules in this part apply to the preparation of welding procedure specifications and the qualification of welding procedures, welders, and welding operators for all types of manual and machine welding processes permitted in this part. That is the scope in one sentence. Any welding process, SMAW, GTAW, GMAW, SAW, FCAW, PAW, ESW, EGW, laser, electron beam. If it is a manual or machine welding process and it is permitted in Part QW, the rules of this part apply. Now QW 100 establishes what the slide calls the three-document system. We introduced these in Part QG. Here in Part QW they get their process-specific definitions, their forms, and their governing articles. Let me walk across the 3 columns. The WPS, Welding Procedure Specification, governed by Article 2, documented on Form QW 482. The WPS is the written instruction that tells the welder exactly how to make a specific weld. It must address every variable, essential, non-essential, and supplementary essential when required, for the process being used. The code states in QW 101 that a WPS shall address, as a minimum, the specific variables both essential and non-essential as provided in Article 2 for each process used in production welding. When must it exist? Before production welding begins. It must be at the workstation. It is written by the manufacturer or contractor and qualified by a supporting PQR. The PQR, Procedure Qualification Record, also governed by Article 2, documented on Form QW 483. The PQR is the permanent evidence that the welding process, as defined in the WPS, produces joints with acceptable mechanical properties. It records the actual variables used during the test weld and the actual test results. It cannot be altered after certification. The PQR is retained by the manufacturer or contractor that performed the qualification. It supports the WPS. One PQR can support multiple WPS documents. And here is the portability rule from QW 100.1. The code states that WPS, PQR, and WPQ prepared under Section IX may be used for any ASME construction code without requalification. If you qualified a procedure for Section 8 pressure vessel work, that same qualification is valid for Section 1 power boiler work, Section 3 nuclear component fabrication, or ASME B31.3 process piping, without any additional testing. The WPQ, Welder Performance Qualification, governed by Article 3, documented on Form QW 484 for welders and QW 485 for welding operators. The WPQ proves that a specific individual has the skill to produce sound welds using a qualified process. The basic criterion, stated explicitly in QW 102, is to determine the welder's ability to deposit sound weld metal. For a welding operator, the criterion is to determine the welding operator's mechanical ability to operate the welding equipment. The WPQ is retained by the current employer. It is valid until continuity expires. Under QW 322, continuity lapses if the welder has not used that welding process for 6 months. WPQ records have limited portability to a new employer, provided records are available and continuity requirements are met. QW 100.2 establishes that welders and welding operators are qualified differently. Not slightly differently, significantly differently. And using the wrong qualification test for the wrong person is one of the most frequent findings in Section 9 audits. So let's get this right. The code's definitions, which we encountered in QG 109, are precise. A welder is one who performs manual or semi-automatic welding, a person whose manual skill and dexterity directly determine weld quality. The welder controls the arc, the torch position, travel speed, filler metal feeding, and weave pattern by hand. If the human hands come off the controls, the weld stops or degrades immediately. A welding operator is one who operates machine or automatic welding equipment. The equipment controls the arc parameters. The operator monitors the process, adjusts set parameters on the controller, and ensures the machine is running within specifications. The quality of the weld is determined primarily by how well the machine is set up and monitored, not by the manual dexterity of the person watching it. Look at the process examples on each side of the slide. Welder processes. SMAW stick electrode, full manual. Every variable is in the welder's hands. GTAW TIG welding with manually fed filler rod. GMAW semi-automatic, the wire feeds automatically but the welder positions the gun manually and controls travel. FCAW semi-automatic. Oxyfuel welding, welding operator processes. SAW submerged arc, machine-driven wire feed and travel carriage. GMAW fully automated or robotic. Electroslag welding, electrogas welding, orbital welding systems, CNC-controlled pipe orbital systems. Why does this matter practically? Position qualification is a major variable for welders. A welder must be tested in the specific positions they will use in production, and the code tables in Article 3 define exactly which test positions qualify which production positions. Welding overhead is a completely different physical skill from welding flat, and the code recognizes that by requiring separate qualification. For a welding operator, position is far less critical. A welding operator qualified in one position generally qualifies for all positions when the process is mechanized. The machine does not get tired, gravity affects it differently, and manual dexterity is not the variable. The forms, QW 484 for welder performance qualification. QW 485 for welding operator performance qualification. These are different forms precisely because they track different essential variables. If you have a saw operator at a sub-arc welding machine who is being tracked on a QW 484 welder form, that is a quality system error. They should be on QW 485. And if you have a TIG welder being tracked on QW 485, that is also an error in the other direction. Now we come to the most important practical skill in this lecture. QW 100.3 introduces the 4-column variable table system that you will use every single time you evaluate a WPS change. Every welding process in Section 9 has its own variable table in Article 4. SMAW has QW 253. GTAW has QW 256. GMAW has QW 255. SAW has QW 251. And so on through every process addressed by the code. The structure of all these tables is identical, 4 columns, each with a specific meaning. Let me take you through each column precisely. Column 1, Essential Variable. Label, WPS and PQR. An X in this column means the variable is essential for procedure qualification. A change in this variable requires a new PQR. You must weld a new test coupon, run new mechanical tests, and certify a new record before the revised WPS can go to production. This column applies to both the WPS, in terms of what range you must specify, and the PQR, in terms of what range was actually tested. If your PQR tested a process on P number 1 carbon steel, and column 1 has an X for change in P number, you cannot use that same PQR to support a WPS for P number 8 austenitic stainless steel. New PQR required. Column 2, Supplementary Essential Variable. Label, toughness only. An X in this column means the variable is supplementary essential. These variables only become additional essential variables when the referencing construction code requires toughness testing, specifically Charpy impact testing. When toughness testing is required, supplementary essential variable changes carry the same weight as essential variable changes, new PQR needed. When toughness testing is not required, and for many Section V8 Division 1 applications it is not, supplementary essential variables are simply irrelevant. They do not apply, they do not need to be addressed. This column exists because toughness is sensitive to welding thermal cycle parameters, heat input, interpass temperature, preheat, in ways that strength and ductility are not necessarily affected by. So the code created a separate tier of variables that only activates when toughness is on the table. Column 3, Non-Essential Variable. Label, WPS only. An X in this column means the variable is non-essential. A change to a non-essential variable does not require a new PQR. You revise the WPS, update the revision number, document what changed, and continue. No new test coupon. No new mechanical tests. This column applies to the WPS only. The PQR does not need to record non-essential variables. The WPS must address them, because the WPS is the instruction set for the production welder. But if they change, the existing PQR remains valid. Column 4, Performance Qualification. Label, WPQ only. An X in this column, which appears in the QW 350 series performance qualification tables, means the variable is essential for the welder's personal qualification. A change in this variable requires the welder to take a new performance qualification test. This column is only in the welder and operator performance qualification tables, not in the procedure qualification tables. The WPQ is about the person. The WPS, PQR is about the process. They are tracked separately. Now the reading rule at the bottom, and this is where people make mistakes. An X means that variable applies. A blank means that variable does not apply to this particular process or qualification type. Here is the trap. People sometimes see a blank and think, since nothing is marked, I can change this freely. That is incorrect. A blank means the variable simply does not apply to that process, not that you are free to ignore it. For example, shielding gas variables are blank in the SMAW table because SMAW has no shielding gas. That does not mean you can introduce any gas you want. It means the concept does not exist for SMAW. And finally, not applicable is not the same as allowed to change freely. Before changing any parameter on a WPS, you identify the variable, find its paragraph number, look it up in the correct process table, and read the column it falls in. That is the complete decision process. 3 short paragraphs that are easy to skim past, and important not to. QW 101, Scope of Article 1. The code says, a WPS used by an organization that will have responsible operational control of production welding shall be a WPS that has been qualified by that organization in accordance with Article 2, or it shall be an AWS Standard Welding Procedure Specification listed in Mandatory Appendix E and adopted by that organization in accordance with Article 5. 2 paths to a valid WPS. Path 1. Qualify it yourself through Article 2. Weld a test coupon, run mechanical tests, certify a PQR. Path 2. Adopt an AWS Standard Welding Procedure Specification, an SWPS, which is a pre-qualified procedure published by the American Welding Society and listed in Appendix E of Section 9. Article 5 governs how SWPS documents can be adopted. We cover that in Lecture 17. Article 1 does not itself qualify any procedure. It defines the framework within which qualification happens. The key point is that every rule in Articles 2, 3, 4, and 5, the hundreds of paragraphs covering test coupons, test specimens, acceptance criteria, variable tables, and performance testing, all sit on the structural foundation that Article 1 lays. QW 102, Method of specifying variables. Welding variables are specified in Article 4, the 400 series paragraphs. Each process has its own variable table in QW 250 through QW 288 for procedure qualification, and in QW 350 through QW 388 for performance qualification. An important practical point is embedded here. Where a variable table lists a variable as not applicable to a given process, that variable does not need to be addressed on the WPS. Only variables referenced by the applicable process table are required on the WPS. This prevents WPS documents from becoming cluttered with variables that have no bearing on the process being used. For a combination WPS, a procedure that uses more than one welding process, like GTAW root and SMAW fill, each process brings its own variable table requirements. The WPS must address the applicable variables from each process's table. QW 103, Records. This paragraph closes Article 1 with the administrative anchor. QW 103.1 restates the organizational responsibility from QG 106 at the Part QW level. Each organization shall conduct the tests required to qualify the welding procedures used in construction, and the performance of welders and operators who apply those procedures. No delegation of this responsibility. QW 103.2, Records, states that each organization shall maintain a record of results obtained in procedure and welder and operator performance qualifications. The forms are in Non-Mandatory Appendix B, QW 482, QW 483, QW 484, QW 485. 3 things to anchor from QW 103. First, records must be certified by the manufacturer. Not by a third party. Not by the authorized inspector. The manufacturer certifies their own records. The AI reviews them. Second, records must be available for review by the authorized inspector at any time. No advance notice clause. An AI can walk in and ask to see records on the spot. Third, Section 9 sets no destruction or expiry date for records. The practical and best practice position is, retain permanently. QW 110 introduces the 4 fundamental weld orientations. These are the building blocks on which all position notation in Section 9 rests. You cannot read the test position tables, which we cover in depth in Lecture 4, without understanding these 4 orientations. The code is brief here. It states, the orientations of welds are illustrated in Figure QW 461.1 or Figure QW 461.2. The figures show plate and pipe orientations respectively. Let me describe each orientation and explain its practical implications. Flat, designation F. The weld axis is horizontal or near horizontal. The code allows up to 15 degrees from horizontal. The weld is made from above, depositing metal down into the joint. In Section 9 notation, groove welds in the flat position are 1G. Fillet welds in the flat position are 1F. This is the most productive position. Gravity works with you, the molten pool settles into the joint. You can use the widest weave bead, the highest travel speed, and for processes like SAW the deepest penetration. It is the foundation of most shop fabrication work where the workpiece can be rotated or positioned. Horizontal, designation H. The weld axis is still horizontal or near horizontal, same 15-degree allowance. But the weld face is approximately vertical. Think of a horizontal seam weld on the side of a vertical plate, or a nozzle-to-shell weld where the nozzle points sideways. Groove welds in the horizontal position are 2G. Fillet welds are 2F. The challenge with horizontal welding is gravity acting sideways on the weld pool. The molten metal tends to sag, to roll down the face, causing undercut at the top toe and overlap at the bottom. Good horizontal welding technique involves controlling arc energy, bead width, and travel speed to manage that sag. Vertical, designation V. The weld axis is vertical or near vertical, between 15 and 80 degrees from horizontal. Welding can be done uphill or downhill. Uphill vertical is 3G ascending, written 3G up pointing arrow. Downhill vertical is 3G down pointing arrow. For fillet welds, 3F. Uphill vertical welding, progressing from bottom to top, generally produces better penetration and better mechanical properties because the arc pushes the pool upward, giving more time for gas and slag to escape, and the preceding weld metal below acts as a shelf. It is the harder, slower, more disciplined direction. Downhill vertical welding is faster, you are welding with gravity, and is used for thin materials and certain processes where heat input must be controlled. But for some materials and some applications, downhill is restricted or prohibited because the faster travel can trap slag and produce less fusion. Some WPS documents explicitly specify the permissible progression direction, and as we noted in the definitions lecture, weld progression direction is an essential variable for certain processes. Overhead, designation O. The weld is made from below, with the weld deposited upward against gravity. The weld axis can be anywhere from horizontal to near vertical. The defining characteristic is that the weld face is downward and the welder works from underneath. Groove welds in the overhead position are 4G. Fillet welds are 4F. This is the most physically demanding and technically challenging position. The molten pool has to be held in place against gravity purely by surface tension, arc force, and shielding gas pressure. Bead sizes must be smaller, travel speed more controlled, and current and voltage carefully managed to prevent drips and cold laps. Overhead welding qualifications typically come with higher pay rates in production, which reflects the skill premium involved. Now, the numerical and letter notation. The number gives the position. 1 is flat, 2 is horizontal, 3 is vertical, 4 is overhead. The letter gives the weld type. G is groove, F is fillet. So 3G is a vertical groove weld test coupon. 2F is a horizontal fillet weld test coupon. These designations carry directly through to the test position qualification tables in Article 1 and the qualification range tables in Article 3. Now let's make the 4-column system concrete by reading an actual table together. We are looking at a portion of QW253, the procedure variable table for shielded metal arc welding, SMAW. This is the most common welding process table in Section IX and the one most engineers encounter first. I am going to walk you through each row and tell you exactly what it means in practice. QW402.1, change in groove type, V, U, J, square. Column 3 has the X, non-essential. If you change your groove geometry from a 60-degree V groove to a U groove, you can revise the WPS and keep welding. No new PQR required. Groove type affects joint preparation and fit up but does not significantly change the mechanical properties of the deposited weld metal. QW402.4, change in backing, removal or addition. Column 3 again, non-essential. Adding or removing a backing material from a V-groove joint is a WPS revision. This makes sense for SMAW because the backing does not fundamentally change what the electrode deposits. QW403.1, change in P number, base metal group. Column 1, essential, X in the essential column. If you change the base metal P number, for example from P number 1 carbon steel to P number 3 alloy steel, you need a new PQR. Base metal chemistry and weldability characteristics change significantly across P numbers, and those changes affect the mechanical properties of the joint. QW403.5, change to or from P number 5, 9, or 10. Column 1, essential. These are the special P numbers for higher alloy steels, the crossing Mo alloys in P5, the Ni alloy steels in P9, and the heat-treatable steels in P10. They get their own essential variable because qualification on ordinary carbon steel does not validate procedure for these demanding materials. QW403.6, T-limit change for toughness procedures. Column 2, supplementary essential. The base metal thickness limits for toughness qualified procedures only becomes essential when toughness testing is required. If you are not required to Charpy test, this variable is irrelevant. QW404.1, change in F number, filler metal class. Column 1, essential. Change the filler metal F number and you need a new PQR. Different F number filler metals have different usability characteristics and can deposit weld metal with meaningfully different mechanical properties. QW404.5, change in A number, deposited weld metal chemistry. Column 1, essential. The A number classifies the chemistry of the deposited weld metal. A different A number means a different alloy composition in the weld. That directly affects mechanical properties, tensile strength, toughness, corrosion resistance. New PQR, QW404.12, change in filler metal classification. Column 3, non-essential. The specific AWS classification of the electrode, E7018 versus E7016 for example, within the same F number and A number, is non-essential. WPS revision only. Both electrodes deposit similar chemistry with similar usability. QW406.1, decrease in preheat temperature. Column 2, supplementary essential. A decrease in minimum preheat is conditional on toughness testing requirements. If your application requires Charpy testing, decreasing preheat affects the cooling rate and the resultant toughness of the new PQR needed. If no toughness testing is required, revise the WPS. QW407.1, addition or deletion of PWHT. Column 1, essential. This is one of the most commonly tested essential variables. Adding post-weld heat treatment to a procedure that was qualified without it, or removing PWHT from one that required it, fundamentally changes the mechanical properties and microstructure of the completed joint. New PQR required without exception. QW408.1, change in shielding gas type. Column 1, essential. Wait, does SMAW use shielding gas? No, it does not. Shielding in SMAW comes from flux on the electrode coating. So why is there an essential variable for shielding gas? Look again. The reading rule tells you, blank means the variable does not apply to this process. If QW408.1 shows an X in the SMAW table, it does apply because SMAW does have shielding considerations through flux composition. But if I were looking at this row in a different context, say for a process that truly has no shielding component, it would be blank, meaning irrelevant. QW409.1, change in current type or polarity. Column 1, essential. DCEP, DCEN, and AC produce different arc characteristics, different penetration profiles, and different deposition rates. Changing polarity changes the weld. New PQR required. QW410.1, change from stringer to weave bead. Column 3, non-essential. Bead technique, whether the electrode is moved in a straight line or oscillated side to side, is a non-essential variable for SMAW. Revise the WPS. QW410.6, method of back gouging or back welding. Column 3, non-essential. Whether you grind back the root pass and deposit a back weld, or use air arc gouging. That choice is a WPS revision. The reading rule at the bottom of the slide. X in column 1 means new PQR if change. X in column 2 means new PQR only when toughness testing is required. X in column 3 means revise the WPS only. No X, blank, means the variable does not apply to SMAW. Practice reading this table until you can go through it quickly and confidently. When you can do that for SMAW, pick up QW256 for GTAW and run through the same exercise. The structure is identical, but some variables appear in different columns because GTAW has shielding gas, tungsten electrode type, and backing gas, variables that simply do not exist for SMAW. This slide gives you the complete end-to-end qualification flow, from the moment a construction code identifies a need for a WPS, all the way through to a qualified welder making the first production weld. Let me walk you through it. Step 1. Need identified. A construction code, say, ASME Section 8 Division 1 for a pressure vessel, references Section 9 and requires that all pressure-containing welds be made to a qualified WPS. That triggers the whole process. Step 2. Write the proposed WPS, PWPS. The manufacturer writes a proposed WPS. The lowercase p stands for proposed. Every variable is listed. Process, base metal P number, filler metal F number, joint design, position, preheat, PWHT, electrical parameters, technique. At this point it is proposed, it has not been validated by test. Step 3. Weld the test coupon. Using the PWPS as the instruction set, a test coupon is welded. All actual variables used during the test, not target values, but what actually happened, must be recorded. The test is run under the full supervision and control of the qualifying organization, as required by QG 106. Step 4. Mechanical tests. Test specimens are extracted from the completed coupon and tested. For groove weld procedure qualification under Part QW, the required tests include tension tests per QW 150 and guided bend tests per QW 160 at minimum. When toughness testing is required by the referencing construction code, Charpy impact tests per QW 171 are also required. Step 5. Record on the PQR. Actual welding variables and test results are recorded on the PQR, form QW 483. The manufacturer certifies it with an authorized signature. It becomes a permanent, unalterable legal document. Step 6. Issue qualified WPS. The proposed WPS, PWPS, becomes the qualified WPS. It is formally linked to the supporting PQR. Any variable range on the WPS that falls outside what the PQR qualifies is not valid. If the PQR tested 10 mm plate, the WPS cannot claim a 50 mm range unless the qualification rules in Article 2 support that extension. Step 7. Welder qualification. Before a welder can use the qualified WPS in production, They must test their personal ability to produce acceptable welds following that procedure. The welder qualification test uses a qualified WPS and is documented on QW 484. Mechanical tests or radiographic examination are used to evaluate the welder. Step 8. Production welding. The WPS is at the workstation. The welder has a current, valid WPQ. The authorized inspector is satisfied with the documentation. Production welding begins. The bottom of the slide shows the records and responsibility summary. WPS retained by the manufacturer or contractor for the life of the procedure. PQR retained permanently by the manufacturer that performed the test. WPQ retained by the current employer while continuity is valid. 6 months without use causes lapse. That chain, from need identification through production welding, is exactly what Section 9 is designed to ensure. Every step has a code requirement behind it, and every link in the chain is documented. In real fabrication, a single weld joint is often made with more than one welding process. The most common combination in pressure vessel and piping work is GTAW for the root pass and SMAW for the fill and cap passes. GTAW root gives you clean, full penetration fusion at the root where radiographic quality is critical. SMAW fill and cap is efficient and versatile for the bulk of the weld deposit. QW 100.1 addresses how combination WPS documents, also called multi-process WPS, work. 4 rules. Rule 1. 1 WPS, multiple processes. A single WPS may specify more than one welding process. This is permitted in common practice. The WPS will list Process 1, GTAW for example, with its applicable variables, and Process 2, SMAW, with its applicable variables. The production welder works from one document. Rule 2. Each process needs its own PQR support. Here is where people make mistakes. The WPS lists 2 processes, but the PQR that supports the GTAW section must be a GTAW PQR. The PQR that supports the SMAW section must be an SMAW PQR. You cannot have a single SMAW PQR support the GTAW root portion. Each process must be independently qualified. In practice, this means a combination WPS typically references 2 PQRs, one for each process. The WPS will state something like, GTAW variables supported by PQR GTAW 001. SMAW variables supported by PQR SMAW 005. Rule 3. Thickness ranges apply per process. The thickness qualification range for a combination WPS is determined by the deposit thickness of each process, not the total joint thickness. Each process must independently fall within its own qualified range. The total weld thickness is the sum of the individual process deposits, but each must be supported by its own PQR for the thickness it contributes. Rule 4. The welder must be qualified in each process. If the WPS uses 2 processes, the welder assigned to that joint must hold a valid WPQ for both processes. This is non-negotiable. You cannot have one welder doing the GTAW root and another doing the SMAW fill and combine their qualifications on one joint. The individual making each portion of the weld must be personally qualified in the process they are using. The example at the bottom of the slide puts it all together. A GTAW root plus SMAW fill and cap WPS must reference a GTAW PQR covering the root deposit thickness, and an SMAW PQR covering the fill and cap deposit thickness. The assigned welder must hold valid GTAW and SMAW WPQs, both current, both with continuity maintained. We touched on portability in the scope slide. Let me go through it completely here because it is a source of genuine confusion in multi-code shops. WPS, PQR, and WPQ portability under QW 100.1. The code is explicit. WPS, PQR, and WPQ prepared under Section 9 are valid for any ASME construction code. Section 1, 3, 4, 8, 1, 12, and B31 piping codes. One qualification effort can support multiple application codes. Practical example. Your shop qualifies a GTAW procedure on P1 carbon steel. You certified the PQR to Section X requirements. That same WPS and PQR is valid when you take a Section 8 Division 1 pressure vessel job, a Section 1 power boiler job, a B31.3 process piping job, or a Section 11 repair job. You do not requalify for each code. Now, portability between companies. WPQ portability, welder performance qualification records, can transfer to a new employer, provided three conditions are met. The records must be physically available. The continuity requirements must have been maintained since the original qualification date, no gap of more than 6 months without using the process. And the new employer must formally accept the records and take on responsibility. This is the path most fabricators use when a new welder joins the team with prior qualifications. PQR portability. This is where the rule is firm in the other direction. A PQR belongs to the company that produced it. Under QG 106, it cannot be taken to a new company and used without that company running their own qualification test. If your company acquires another company's shop and you want to use their procedures, you must produce your own PQR. There is a narrow exception for ownership transfers under QG 107 in the 2025 edition, where the new owner takes full responsibility and quality program documentation requirements are met. But in standard subcontract or vendor situations, PQR portability is not permitted. WPS portability to a new company, same restriction. A WPS references the PQR of the company that qualified it. A new company cannot pick up that WPS and use it in production without their own supporting PQR. When the construction code adds requirements. This is the precedence rule from QG 100. Section 9 sets the floor. Construction codes can build on top of it. Section 8 Division the 1st of May require impact testing under UG 84, mandatory PWHT under UCS 56, and NDE requirements beyond visual examination for certain joint categories. Section 1 requires that the authorized inspector witness the welding of test coupons. Section 3 Nuclear fabrication layers on additional quality assurance program requirements, specifically NQA1 program documentation, that go beyond anything in Section 9 itself. Section 11 Repair and replacement procedures may require pre-approved procedures and additional NDE methods depending on the system classification. B31.3 for Category M high-hazard fluid service imposes stricter examination requirements than standard B31.3 service. The bottom line, Section 9 compliance is necessary but not always sufficient. Check the referencing construction code for what it adds. Where there is a conflict, the construction code wins. 6 takeaways from Lecture 3. 1. Part QW Article 1. QW 100 to QW 199, is the framework for all of Part QW. The 5 articles build in sequence. Article 1 defines the system, 2 qualifies procedures, 3 qualifies people, 4 provides the data, 5 provides SWPS access. You cannot understand Articles 2 through 5 without the foundation of Article 1. 2. A welder and a welding operator are qualified differently, and the correct WPQ form matters. Welder equals manual skill, major position variables, QW 484. Welding operator equals machine settings, fewer position variables, QW 485. Misclassification is a common audit finding. 3. The 4-column Article 4 variable table is the operational heart of Section 9. X in column 1, new PQR. X in column 2, new PQR if toughness testing required. X in column 3, WPS revision only. X in column 4, new WPQ. Blank means the variable does not apply to that process. It does not mean free to change. 4. WPS and PQR are company specific. A PQR cannot be taken to a new company and used without that company qualifying their own procedure. WPQ records have limited portability with conditions attached, records available, continuity maintained, new employer formally accepts. 5. Combination WPS, multi-process procedures, are permitted in common. Each process requires its own PQR support. Each process's thickness range is qualified independently. The welder must be qualified in every process they will use on that joint. 6. QW110 defines the 4 fundamental weld orientations. Flat at 1G, 1F. Horizontal at 2G, 2F. Vertical at 3G, 3F. Overhead at 4G, 4F. These 4 letters and numbers are the building blocks of every position notation in the rest of the course. If these are not completely clear, go back to slide 7 now. In Lecture 4 we go into QW120 through QW133, the specific test positions for groove welds and fillet welds on plate and pipe. We will map out 1G through 6GR, show you what each physical setup looks like, and explain which test position qualifies which production positions. That is a visual and practical lecture, and it builds directly on the orientation foundations we set today. Thank you for watching. Subscribe to Weld Fab World on YouTube for the full series, and visit weldfabworld.com for reference material. That wraps up Lecture 3, QW Article 1, Scope and Structure. All code references in this lecture are from ASME BPVC Section 9, 2025 edition, QW 100 General Scope, QW 100.1 WPS, PQR, WPQ Relationship and Portability, QW 100.2 Welder versus Welding Operator Distinction, QW 100.3 Reading the 4-column Article 4 tables, QW 101 Scope of Article 1, QW 102 Method of specifying variables, QW 103 Records and Responsibility, and QW 110 Weld Orientations. Forms referenced, QW 482 for the WPS, QW 483 for the PQR, QW 484 for Welder Performance Qualification, and QW 485 for Welding Operator Performance Qualification, all in non-mandatory Appendix B of Section 9. This material is for educational purposes. Always refer to the current edition of ASME BPVC Section 9 for requirements applicable to your specific project.